In section 12.6, we are going to be looking at adding and subtracting rational expressions with like denominators. That means the denominators are going to be the same. I want you to think back to just adding fractions together. We're going to be doing that today, except we have variables that are also included. Remember, we can only add or subtract fractions when the denominators are the same. So just as a review, our first one is 5/7 plus 9/7. Obviously the denominator is the same, so we can add these together as 5 plus 9 over 7. Now, this is just a general overview, and so 5 plus 9 is 14 because they are like terms, and 14 over 7 we can reduce. This will be possible in some cases, which leads us to an answer of 2. Now, that's not always going to be the case that will reduce, but it might be in some cases. Our next one we have a 2x in both denominators, and so we can add them once again. Our numerator is x plus 12 plus the second x, and now we're over one common denominator of 2x. We look at our numerator and we identify what are our like terms. I'm going to circle them. That's x and x. That's actually 1x and 1x for both. That gives us 2x plus 12 divided by 2x. Now we need to analyze. And very simply, what are we analyzing? We analyze if all three coefficients are able to be divided by the same thing. So all three, both the 2 and the 12 and the 2, can be reduced. So we need to analyze if all coefficients can be reduced. Hopefully you're seeing that all three of those can be divided by 2. That leads us then to x plus 6 over x. Now, we would love to be able to cancel out these two x's, but we do not have an x that we can cancel with the 6, so that's as far as we can go, and that is our answer. Moving down. Once again, we're going to try to combine our like terms. We analyze our denominators, and I see that both of our denominators are the same, so I'm going to rewrite this all with one denominator. On the left I have the 2x plus 5, on the right I have the 4x minus 7. I'm going to circle my like terms, the 2x and the 4x. That gives me 6x. I'm going to box in my other like terms, positive 5 and negative 7. That gives me a minus 2 over x plus 1. Here, once again, I'm going to identify and focus on my coefficients, 6, 2, 1, and 1. And I see between all four of those there's nothing that goes into all four. And so my answer is still 6x minus 2 over x plus 1. So on problem 2, we were able to cancel, but on problem 3, we were not. Here we have our last one. Once again, they have the same common denominator, so we can combine them. 6 minus 4x plus 3x minus 4. Let's focus first on our x's. That's a negative 4x. I'm circling the negative in front as well, and a positive 3x. Those two combine to negative 1x. Now we look at our numbers. Our positive 6 and our negative 4. That's a minus 2. That's divided by x minus 2. As we look at that, we have to determine, does anything cancel between these two? Well, as we're looking at the top, we realize that actually this is negative x plus 2 because the 6 minus 4 is a positive 2. Negative x, positive 2, negative 2. If I helped you and rewrote the top as 2 minus x and the bottom as x minus 2, maybe you'll see that these two numbers are actually opposites. And remember, opposites cancel to negative 1. So, in actuality, these do cancel because they happen to end up to be opposites. That's going to be a very rare occurrence, but it will happen on a rare occasion. As we continue to look, we're going to look at the second part, which has a couple different illustrations and a couple different scenarios. My note up here in italics says, pay attention to distributing a negative sign in front of the fraction as a binomial in the numerator. What does that mean? If we have this minus sign here, as we're working it out, realizing it's all x over x minus 2, we've got x plus 4 in parentheses minus a 2x plus 2 in parentheses. In light of that, what we're going to have is we're going to need to distribute that minus sign to both the 2x and to the 2. And so that's going to become minus 2x minus 2 all over x minus 2. Now I'm going to combine my like terms. 1x minus 2x is negative 1x. And 4 minus 2 is a plus 2 all over 1x minus 2. Now, maybe from the previous problem you realize that this top could be written in reverse order. And then you can see that once again we have opposites, and realize opposites cancel to negative 1. Now this is not always going to be the case, but because they're opposites and they cancel to negative 1, that's going to allow us to work through it. Important point to remember on this last one, distribute the negative to both parts of the following fraction in the back half. Our last one here, we have x plus 3 in the denominator, we have 4x plus 7 in the first part, minus x minus 2 in the second part. So we're going to distribute that minus sign in the back half, minus x plus 2 all over x plus 3. Our common terms are 4x and negative x, that's a 3x, 7 and 2, that's a 9, divided by x plus 3. Now in this case we're always going to look to simplify, and we ask ourselves, does anything factor out of the top half? Always look to see, can we factor out of GCF? In this case we can. The GCF is 3. So let's take a 3 out. 3 times x is 3x, and 3 times 3 is 9, divided by an x plus 3. Because they're connected by multiplication, and the top and the bottom both have an identical x plus 3, those two will cancel. That leaves you with an answer just of 3. So I've tried to show you a couple of different illustrations, some where opposites cancel at the end, some where you can factor out a GCF and they cancel at the end, or on the front page where we have problems that are adding together, and then those are possibly going to cancel, or they may not cancel, like in number 3. So as we're looking through this, we want to make sure that we are focusing on adding or subtracting, carefully distributing the negative if they're subtracting, and that should lead us to some success.